Adding and subtracting rational expressions is going to be very similar to adding and subtracting just regular fractions. So if I gave you a problem of 1/5 plus 3/10, hopefully you remember from elementary school that we would need to find a common denominator first, right? So let's look at the factors of our denominators. The number 5 can't be broken down into smaller factors, but the number 10 can. It's the same thing as saying 5 times 2. So what factor is missing from this denominator to make it exactly the same as this denominator? Hopefully you see the number 2. That's what's missing. So I'm going to go ahead and multiply this denominator by the number 2 so that it will match this one. However, I'm not allowed to just multiply the denominator by the number 2. I have to multiply the numerator by 2 also. Now, why is this legal? If I multiply both the numerator and the denominator by the exact same value, all we've done is multiply by the number 1, right? 2 divided by 2 is equivalent to 1. Any expression divided by itself is equivalent to 1. So as long as we do that, we keep our fraction balanced. So what does this turn our problem into? Our first fraction turns into the number 2/10. And then we didn't do anything to change the second fraction. It's still a 3/10. So 2/10 plus 3/10 is 5/10. And of course, when I look at 5/10, I see that both the numerator and the denominator are divisible by 5. So let's divide both of these by 5. And our answer simplifies to 1/2. Now, it doesn't always simplify, but if it does, we probably should simplify it. There's our answer. So here are the steps when we're adding and subtracting rational expressions. The first thing you want to do is factor your denominators if possible, which is what we did right here. The next thing you need to do is list any of your repeated terms only once to create your new least common multiple. We want the smallest common multiple between the two denominators. And then we're going to multiply each fraction by the missing term over the missing term. All right, so let's just take an example really fast of finding least common multiples. So if I look at 3x squared and 9x minus 18, well, 3x squared is the same thing as saying 3 times x times x. That's broken down as much as it possibly can be broken. Now, this 9x minus 18 can be broken into 9 times x minus 2, right? We've factored out the number 9, but the number 9 can also be broken down into 3 times 3 times x minus 2. So let's go ahead and look at these. We've got 3 times x, and we have 3 times 3 times x minus 2. All right, so what are the common factors that they both share? Well, I see they both have the number 3, so I'm going to list that one time. Now, what else do these have in common? They don't have anything else, so we've got to list every single other factor out. So this number 3, I need to list again. Both of these x's, or x squared, needs to be listed. And then this x minus 2 needs to be listed. Oops, x minus 2. So the least common multiple between 3x squared and 9x minus 18 is going to be a 9x squared times x minus 2. That's the least common multiple, okay? So let's apply that to a problem. If we ask you to simplify 2 divided by 5x minus 1/6, we need to find the least common multiple first. And the factors of 5x are just 5 times x, and the factors of 6 is just 6, right? So they don't have anything in common. So my first fraction, I'm going to go ahead and multiply by the number 6, which means I have to multiply my numerator by the number 6 also. And my second fraction will multiply by 5x, which means I have to multiply my numerator also by a 5x. Right? So now they're both exactly the same. 5x times 6, 5x times 6. They have the exact same denominator. If there's no common factor between the two, you're just going to multiply the denominators by each other. All right, so my first fraction turns into a 12 over 30x. Then we have minus, and our second fraction turns into a 5x over 30x. Now that they have a common denominator, we can go ahead and combine their numerators. So that gives us 12 minus 5x over 30x. And if I look at my numerator, I don't have a GCF. There's no way that I can factor that and see if it reduces with my denominator at all. So that's my final answer. All right? So let's try a couple more problems. Remember, these are the steps that you need to add and subtract your rational expressions. So find your common denominators if possible. Factor your denominators if possible, I meant to say. So this first example, we have x minus 4 and an x plus 6. I can't factor those at all. Those are linear factors already by themselves. So all I've got to do is multiply my first denominator by x plus 6. And I'm going to multiply my second denominator by x minus 4. It's whatever they're missing. So now they both have an x plus 6 times an x minus 4. Now make sure that your first fraction, to keep it balanced, you also multiply the numerator by an x plus 6. And in our second fraction, you also have to multiply its numerator by an x minus 4. Remember, you've got to keep your fractions balanced. Okay, you can't change their value. You're multiplying by that magical number 1, right? All right, so my first fraction, let's multiply 3 times x and 3 times 6. Gives us 3x plus 18 over. And I'm not going to go ahead and double distribute my denominator. I'm just going to keep it as x plus 6 times x minus 4. And then our second fraction, 2 times x gives us 2x. And 2 times our minus 4 gives us a minus 8. All over x plus 6 times x minus 4. And our end goal is going to be to simplify our fraction as much as possible. That's why I'm leaving my denominator factored out right now. All right, so let's combine these two fractions together. We're adding the fractions. And when you add fractions, you add their numerators, right? Once they have a common denominator. So what do they have? What are our like terms? 3x plus 2x. That gives us a 5x. And then, of course, we have our 18 plus our negative 8, or 18 minus 8. 18 minus 8 gives us a positive 10. So we have plus 10 all over our denominator of x plus 6 times x minus 4. So we've simplified this, but if I look at my numerator, I see that 5x plus 10 does have a GCF. I can factor out the number 5. So this is equivalent to 5 times x plus 2 over x plus 6 times x minus 4. So this right here is an answer. And we went ahead and we factored our numerator just to see if anything else could reduce, but it doesn't. So they are the same exact value. Okay, either of these answers will suffice. Okay, let's look at one more example. We have 3 divided by x squared minus 64 minus 2x over x minus 8. The first thing you want to do is factor your denominators if possible. And I do see that my first denominator is an x squared minus 64. This is the difference of two perfect squares. I'm going to go ahead and rewrite these. So x squared minus 64 is the same thing as saying x plus 8 times x minus 8. So all I've done is factored my denominator. My second fraction has a denominator of just x minus 8. There's no way to factor that. So what do they have in common? Well, I see that they both have an x minus 8, but this denominator also has an x plus 8. So I need to go ahead and multiply this denominator by x plus 8 so that they now have a common denominator, which means I still need to multiply this numerator by x plus 8 also. Now, I don't need to do anything to this first fraction because just by multiplying the second one by x plus 8, they now match. We now have a common denominator, so I can leave that first one alone. So let's go ahead and simplify this. There's nothing I can do to my first fraction, 3 over x plus 8 times x minus 8 minus, and this next fraction, we have 2x times x, which gives us 2x squared, and we have 2x times 8, which gives us our plus 16x. And of course, our denominator is still x minus 8 times x plus 8. Okay, so now we have our common denominator, and our numerators are written in such a way in expanded form that we can combine them together. The only tricky part about a subtraction problem is you have to remember to subtract every term in your numerator. Both of these terms or signs are going to change, right? So our new numerator is going to be 3 minus 2x squared minus our 16x. That minus distributes to both of those values, all over x plus 8 times x minus 8. Now, generally speaking, you would write this in standard form, right? You would write your exponent or your term with the highest exponent first, and then work your way in descending order. But truly, this answer right here is correct. But let's go ahead and put it in standard form, our numerator in standard form. Negative 2x squared minus 16x plus 3 over x plus 8 times x minus 8. And there's nothing I can do to factor this numerator right here, okay? I can't factor it, and I would encourage you to go ahead and try. Just double check me and make sure. Always question the man. But 2x squared minus 16x plus 3 is as simplified as I can get, and our denominator is this x plus 8 times x minus 8. And that is how you add and subtract rational expressions.